every type of dwarf planet, space is complicated. We make it simple. A dwarf planet failed one specific test, and that failure is the only reason it isn't called a planet at all. It has to be round. It has to orbit the sun. It just isn't massive enough to have cleared its own orbital neighborhood of other debris. That one missing qualification is the entire reason Pluto lost its status in 2006. And it's the reason an entire category of worlds most people have never heard of quietly exists at the edges of the solar system. We're going in order outward from the asteroid belt to the far edge of the solar system. Then we'll sort them a second way by how strange their individual surface actually is. Because on this list, technically not a planet, and boring turn out to have nothing to do with each other. Ceres. We begin with the only dwarf planet that isn't out past Neptune, and also the smallest one on this list by a significant margin. Ceres sits in the asteroid belt between Mars and Jupiter, and it's large enough, at about 940 kilometers across, that its own gravity has pulled it into a genuinely round shape, unlike the lumpy, irregular asteroids surrounding it. Here's the fact that should genuinely bother you. Ceres appears to have, or have recently had, liquid water beneath its surface. NASA's Dawn spacecraft, which orbited Ceres directly, detected bright reflective salt deposits inside a crater called Okatur, believed to be the leftover residue of briny water that seeped up from underground and evaporated on the surface, evidence of ongoing or recent geological activity on a body most astronomers assumed had been a cold, dead rock for billions of years. Here's the part that lingers. Ceres accounts for roughly a third of the entire mass of the asteroid belt all by itself, meaning this single, quietly overlooked dwarf planet outweighs every other asteroid in that region of the solar system combined, several times over. Pluto. Here's the twist. This is the dwarf planet everyone knows, and also the reason the entire category exists as an official classification at all. Pluto's 2006 demotion from full planet status wasn't a punishment. It was the direct consequence of astronomers finding several other objects out past Neptune of comparable size, forcing a choice between admitting dozens of new planets into the solar system or creating a new, more precise category. Here's the fact that should genuinely bother you. Despite being demoted specifically for not clearing its orbital neighborhood, Pluto turned out to be one of the most geologically active, visually stunning worlds NASA's New Horizons spacecraft photographed during its 2015 flyby. A vast, heart-shaped plain of frozen nitrogen ice named Sputnik Planitia, mountains made of solid water ice rising several kilometers high, and evidence of possible ongoing geological convection on a world so far from the sun that noon there is roughly as bright as Earth's twilight. Here's the part that lingers. Pluto has a moon, Charon, so large relative to Pluto itself, roughly half its diameter, that the two don't orbit in the way a planet and a smaller moon normally do. Instead, they orbit a shared point of gravity that sits in the empty space between them, technically making Pluto and Charon closer to a double dwarf planet system than a planet with a satellite at all. Eris. Here's the reframe. This is the dwarf planet that started the entire controversy, and it did it purely by being almost exactly Pluto's twin. Discovered in 2005, Eris is nearly identical in size to Pluto, and for a brief period was actually believed to be slightly larger, which is precisely what forced the International Astronomical Union to finally settle, once and for all, what counted as a planet. Here's the fact that should genuinely bother you. Eris is significantly more massive than Pluto despite their similar size, meaning it's made of denser material, and it orbits on a highly elongated, tilted path that takes it nearly 3 times farther from the sun at its most distant point than Pluto ever travels. A full orbit around the sun takes Eris about 558 years, meaning it hasn't completed a single lap since before the founding of the United States. Here's the part that lingers. Eris's surface is coated in frozen methane, so reflective that it's one of the brightest objects in the entire outer solar system, and astronomers believe that brightness is directly tied to its extreme orbit. As Eris slowly moves farther from the sun over centuries, its thin atmosphere is believed to freeze solid onto the surface as a fresh reflective frost, only to sublimate back into a temporary atmosphere again as it eventually swings back closer in. Haumea. Here's the pivot. This is the strangest shape on this entire list, and the reason is written directly into how fast it spins. Haumea rotates once every roughly 4 hours, making it one of the fastest rotating large objects in the entire solar system, and that extreme spin has stretched its shape into a flattened, elongated ellipsoid, more like a rugby ball than a sphere, despite technically still qualifying as round enough for dwarf planet status under the specific rules used to classify it. Here's the fact that should genuinely bother you. Nobody is entirely certain what caused Haumea to spin this fast in the first place. The leading theory proposes a massive ancient collision, violent enough to have also chipped off a family of smaller icy fragments that share strikingly similar orbital characteristics, effectively making Haumea the parent body of the only confirmed collisional family of objects out in this part of the solar system. Here's the part that lingers. In 2017, astronomers watched Haumea pass in front of a distant star and, to general surprise, detected a thin ring system around it, making Haumea the first trans-neptunian object and the smallest object of any kind ever confirmed to have rings, a discovery nobody had predicted for a world this far from the sun. Makemake. Here's the fact that reframes this entry as the loneliest world on the list. For years after its 2005 discovery, Makemake was believed to be the rare, large trans-Neptunian object without a single moon, an outlier compared to nearly every comparably sized body nearby, most of which have at least one confirmed companion. That changed in 2016 when a very faint, dark moon was finally detected orbiting it, nicknamed MK2, so dark that it reflects barely more light than fresh asphalt, making it almost invisible against the glare of its much brighter parent world. Here's the fact that should genuinely bother you. Makemake's own surface is covered in frozen methane and ethane ice, giving it a distinctly reddish tint visible even from Earth-based telescopes, and its extreme distance and small size mean it remains one of the least studied dwarf planets on this entire list. No dedicated spacecraft has ever visited it, and nearly everything we know comes from distant telescope observations and a small number of stellar occultation events, brief windows where Makemake happens to pass in front of a background star. Gonggong. Here's the twist. Not every dwarf planet candidate has been officially unanimously confirmed, and Gonggong sits right at that contested edge. Roughly the size of Haumea Gonggong orbits on a wildly tilted, elongated path that takes over 500 years to complete a single loop around the sun, and it carries a single known moon, Xianglu, discovered via the Hubble Space Telescope. Here's the fact that should genuinely bother you. Gonggong's reddish surface color is believed to come from tholins, complex organic compounds formed when ultraviolet sunlight and cosmic rays break down simple ices like methane over billions of years, meaning the same basic chemistry involved in forming some of the building blocks of life elsewhere in the universe is quietly happening in extreme slow motion on the frozen, sunlight-starved surface of a world most people have never heard of. Here's the part that lingers. Because Gonggong hasn't been formally accepted onto every official list of confirmed dwarf planets, it exists in a genuine gray area of solar system classification. Round enough, large enough, and orbiting the sun independently enough that most astronomers informally treat it as one anyway, even without full bureaucratic confirmation. Sedna. Here's the fact that closes this list on its most isolated, most mysterious note. Sedna's orbit is so extreme that it makes every other object on this list look ordinary by comparison. At its closest approach, it's still roughly twice as far from the sun as Neptune, and at its farthest point, it travels out to nearly 900 astronomical units, deep into a region of space with no other confirmed large body anywhere near it. A single orbit takes Sedna somewhere between 11 and 12,000 years to complete, meaning it hasn't returned to the point in its orbit where it was first discovered since roughly the end of the last ice age, and won't again until long after every currently living human is gone. Here's the fact that should genuinely bother you. Sedna's extreme, isolated orbit doesn't fit cleanly into any standard model of how the solar system formed. Some astronomers propose it was gravitationally tugged outward by a passing star sometime in the solar system's early history, while others have pointed to Sedna's orbit along with a handful of similarly extreme objects as indirect evidence for an undiscovered, much larger planet still lurking in the outer darkness, sometimes called Planet 9, whose gravity could explain why these objects share such improbably similar stretched out orbital alignments. Here's the part that lingers. Nobody has confirmed Planet 9 exists. Sedna itself is the closest thing we have to physical evidence that something else, out past everything we've directly observed, might still be quietly shaping the solar system from the dark. Quaoar. Here's the fact that closes out the newer, less famous candidates on this list with a genuine physics puzzle. Discovered in 2002, Quaoar orbits out in the Kuiper Belt, and in 2023 was found to have a thin ring system, but a ring system sitting in a location that, according to the standard physics used to explain every other ring system in the solar system, shouldn't be able to survive there at all. Every other confirmed ring, from Saturn's to Uranus's to Haumea's, sits within its parent body's Roche limit, the distance close enough that tidal forces prevent loose material from ever clumping into a moon. Quaoar's ring sits roughly twice as far out as its Roche limit predicts a stable ring should be able to exist, well within the zone where physics says any orbiting debris should have already collapsed into a small moon over time. Here's the fact that should genuinely bother you. Nobody has a confirmed explanation for why Quaoar's ring hasn't done exactly that, and its discovery has forced astronomers to reconsider whether the Roche limit rule, treated as a reliable law for over a century, might have exceptions nobody previously had reason to look for, simply because no one had ever found a ring sitting somewhere the rule said it couldn't be. Let's sort these 8 again a different way, not by distance from the sun, but by how strange each surface actually is. On the geologically alive end, Ceres with its briny salt deposits hinting at recent or ongoing subsurface water activity. On the visually stunning end, Pluto, home to nitrogen ice plains and water ice mountains that surprised even the scientists who spent decades planning the mission to photograph them. On the physically distorted end, Haumea spun into an elongated shape by rotation extreme enough to also explain its unexpected ring system. On the coldest and loneliest end, Sedna orbiting so far into the darkness that its own existence hints at a planet we still haven't found. And on the least understood end, Makemake and Gonggong, both large enough to matter, and both still waiting for the kind of dedicated spacecraft visit that turned Pluto from a fuzzy dot into one of the most surprising worlds in the entire solar system. It's worth being clear before we close about exactly where the official line actually sits, because it's more specific than most people realize. The International Astronomical Union's 2006 definition requires a solar system body to meet 3 conditions to be a full planet. It must orbit the sun, be massive enough for its own gravity to pull it into a round shape, and have gravitationally cleared its orbital neighborhood of comparable debris. Every object on this list fails only that third condition. Each one shares its orbital region with enough similarly sized material that it hasn't gravitationally dominated its neighborhood the way Earth or Jupiter has. Here's the fact that should genuinely bother you. This means the exact same object could, in principle, be reclassified in the future if new discoveries changed how crowded or empty a region is judged to be, meaning even this list itself isn't necessarily permanent. It depends entirely on how much debris astronomers eventually confirm actually surrounds each of these worlds. Here's the last thing worth sitting with. Every object on this list is large enough, round enough, and gravitationally significant enough that, under a slightly different definition adopted in 2006, all of them could have been taught in school as full planets, right alongside Earth and Jupiter. Instead, an entire category of small, strange, distant worlds sits one bureaucratic line short of that title, not because they're boring, but because the solar system, it turns out, has far more round objects in it than the word planet was ever built to comfortably hold. Not bad for stick figures on a rock.